biggest obstacle in the development of electric car market is the lack of infrastructure needed to use such vehicles. It is possible that even after charging the car battery, it will not have enough energy until the next charging station, which can be hundreds of kilometers away in a big city. 3psilon aims to build a series of charging stations that will be independent from the electricity network and which will allow the charging of electric cars with green current produced by solar panels that capture light received from satellites placed in geostationary orbit. With the help of these satellites, the stations will be able to take advantage of the sunlight even at night, they will be able to be located in the most isolated areas of the planet, and they can also be a source of electricity and communication for various communities.
The prototype we propose consists of 3 distinct parts, but which converge towards the realization of the same complex project proposed by 3psilon. Thus, the first part is represented by a program of a small-scale graphical simulation of the operation of the stations and satellites. This simulation is built on an algorithm capable of reading the charge status of each station on Earth and redirecting the light received by satellites to the stations that need the most to be loaded, depending on the crowd and the number of cars that will arrive at every station. This simulation also takes into account the rate at which each car is charged, the maximum capacity of a battery, and randomly chooses a larger or a smaller number of cars that come to charge depending on the time at the respective station.
The second part of the prototype consists in creating a mobile application that can be used by drivers to find the nearest charging stations to choose the right one for both driver's route and optimal for the 3psilon's network. This application will allow us to create a complex database that will help us better understand the needs of users, their car loading schedule and the routes they usually use so that we can optimize as much as possible the entire activity of the stations and the satellites that serve them. Complementary to the application, there will be a site that will have the same functionalities as the application and which, in addition, will offer users scientific and technical information about the entire activity of the 3psilon team.
The last part of the prototype we propose is a functional model of the small-scale project. It consists of an Arduino board that controls 2 distinct satellites. With the help of the associated code, these satellites can redirect light to a globe, and when the light falls on a certain station, its LED will light up. This is possible due to the photoresistors installed on the globe. An associated servo motor for each satellite is responsible for adjusting the angle at which the mirrors transmit light depending on the station that we choose to be loaded.
And all of this is just the beginning of the large-scale project we all dream of. It is just another brick set for a clean future in which technology will help humanity to save and make the most of the nature without any harm. Together we are sure that we can build a safer world, a world in which we will be closer than ever to each other. Together we build a better world.